here together with Roberto, our product manager of Elemental Analyzer, in order to talk about accurate protein determination in multi-ingredient foods. Let's briefly start from the agenda of today. So we will focus at the beginning on the general trend. So what does it mean, multi-ingredient food, and which are the general trend considering the global growth, the different type of multi-ingredient foods, and we will focus specifically on protein bars. So what are protein bars, why they are multi-ingredient foods with different type of protein bars you can find off the market. And then in the end, we will focus on the main analytical challenge, and we will discover together why protein bars are so difficult to be analyzed. But at the same time, we will show the solution of this challenge, because Roberto will explain to you how we have been able to achieve accurate and reproducible results with our NDA702, the Velp Bluma nitrogen and protein analyzer. At the end, we will have a short session dedicated to the question and answer. So if you have any doubt, or if you like to deepen analyze something, just type it in the box you will find on your screen. And in the end, we will answer to some of these questions. And if we will not answer, don't worry, because we will reach you out with the email, giving the right answer to your question, of course. So let's start with a question that is, what do we mean by multi-ingredient food? So there are a lot of different definitions of these words, because there are, of course, differences between culture, countries, and so on. But today, we will focus on a general definition that is a multi-ingredient food is any kind of food that is composed by different ingredients. These ingredients could be agricultural ingredients like grains, fruit, vegetables, processed ingredients like sugar, fats, oil, different flavorings, or synthetic ingredients that could be artificial colors, again, artificial flavors, sweeteners, and so on. So this could be, for example, processed meats, or canned food, or frozen milk, or again, snacks, like we will see later with protein bar. But let's start giving also an overview of the differences that we have from a country and consumption point of view. Because of course there are different type of factors that influences the consumption of multi-ingredient food across the world. We can focus on four main factors. The first one are the economic factor. If you think about this, it's pretty much easy to understand that the countries where people has got a higher income level, of course, the consumption of multi-ingredient foods is higher. There is also a cultural factor, because there are some countries where home-cooked meal or traditional dietary needs are still strong among the population. And of course, here the consumption of multi-ingredient foods is lower than in other. There are also lifestyle factors. If you think, for example, about the Western country, where we are living an always fast life, stepping from a meeting to another, doing a lot of things every day. So this type of food are mostly consumed in this kind of country, where we need also something that is quick and fast to be eaten in those situations where we have got not the possibility to have a full meal. And then there are health trends, because there are some countries like the Western one, where the awareness for health and fitness is stronger than in other. And of course, in this country, the consumption of this type of food is higher than in the others. These factors create then a sort of differentiation between developed countries and developing countries. The developed countries are the one in which, of course, there is a higher per capita consumption of this food. The other, of course, are those countries more related to the consumption of traditional foods and home-cooked foods. As we said, today we are going to focus more on protein bars, which are a particular type of multi-ingredient food because basically they are made by different type of ingredients. This ingredient could be protein, for example, that could be plant-based or animal-based, carbohydrates like oats, brown, rice, nuts, seed, fats, where we can find again nuts, seed or nut butters, sweeteners like honey, but also artificial sweeteners, flavoring that could be vanilla, fruits, chocolate, and other ingredients like vitamins, minerals, fiber, and so on. All these elements are put together, you know, in order to create a convenient, portable, and well-based nutritional food. That is basically the aim of multi-ingredients food. So giving to the people the right amount of, the right balance of nutritional in something that can be easy and quickly consumed. From a global point of view, if you think about this, there was a time where people were used to think that protein bars was just consumed by people passionate of, enthusiastic of fitness. But today this trend is of course changing, and there is here by here an higher amount of people that daily consumed this type of multi-ingredient food, so protein bar. These are mainly related to the fact that people are day by day more aware about fitness and health, and in so doing they are always seeking convenient way to meet their nutritional needs. And protein bars are widely recognized for their ability to offer a quick protein boost that is essential for muscle, weight management, and the overall health of people. Additionally, we have to take into consideration how our lifestyles is changing, especially in some countries where we have said we are living an always fast life, stepping from a meeting to another, from an activity to the other. And so we need something that can easily and quickly consumed, even when we are not able to have a full meal that requires, of course, more and more time in a day. All these changes, also considering the changes in the diets, for example, vegan people, vegetarian people, people that cannot eat lactose and so on, speed up innovation in the world of protein food, of protein bars. And if you think about it, nowadays you can find any type of protein bars in order to suit any type of dietary requirement. From a geographical point of view, the main market of protein bars is represented by the North American countries. Here, the market has got roughly the 37% of the global market, and these are the results until the last year. Then there is the Europe, where the awareness of fitness, where the more health-conscious people and seeking convenient nutritional snacks bring people to consume every day this type of protein source. And here, the growth between this year and 2030 is expected to be to reach the 5.9. And then we have the Asian and Pacific countries, which are developing countries where people tend every day to adopt a sort of Western lifestyle diet. And also here, the consumption of protein bars is growing year by year, and this growth should reach the 6.5% at the end of 2030. But of course, the producers, so the companies, the industry, and also the laboratory that work with food manufacturers has got to analyze this protein content. for a different series of goals, basically, and reasons. One of these is, of course, the nutritional labeling, because accurate protein determination information are essential for consumer to make informed dietary choice. Then we have also health assurance, because of course the authenticity of ingredients enable to prevent any type of fraudulent practices. Then quality control, because of course we need to ensure that the product has got a specific level of quality before putting this on the market. Then regulatory compliance, because of course the adherence to food safety standard is a must in food industry. Product development, because as we said, we need to cover an always wider requirement of different type of protein bar, different type of dietary requirement. And so in so doing, we can day by day find new type of product, adding different type of ingredients to reach the final product, and then a process optimization, because monitoring process level during the production can help identifying some inefficiencies and then of course improve the production step, the process of production. Now we are going to explain, to analyze what are the main challenges, because we have said that protein bars are every day consumed by a higher amount of people. We have said why they are important, so why people decide to consume these. We have said why it is important for producer and laboratory to analyze the protein content, but which are the main challenges? Because we said that protein bar are made up of different ingredients. And so these make protein bar a very hard, a very difficult sample, a very difficult food to be analyzed. First of all, because you have to think about sample preparation. So if they are made of different ingredients, how I can properly prepare the sample in order to get the accurate results I need. The second is the sample amount. So we have said that they are made of different ingredients. So how many, what is the weight of the sample I have to use for my analysis? And the third is the full combustion, because of course, if they are something made up of different ingredients, these ingredients got a different combustion time. These are the main focus, the main topics on which now Roberto, we will focus. And so I invite him to join us and to you to enjoy our expert.
Hello, everybody. Let's start introducing the Velp solution for nitrogen and protein determination. The NDA702 element analyzer works in accordance with official reference methods. And in short, it's a very fast and accurate analyzer able to detect nitrogen in roughly 3 to 5 minutes with an electronic autosampler that can have up to 117 positions. It is a real macro analyzer. This means that can analyze high sample weight and volume, especially useful for inhomogeneous samples. Third, the NDA is suitable for any type of solid samples, such as grains, or liquid samples like milk, providing matrix-independent results and fast and easy routine maintenance. Then the laboratory has the possibility to choose between helium or argon as carrier gas. We will see later the benefits of using one instead of another. The analyzer, based on Dumas combustion methods, use long-life catalysts and non-hazardous reagents. The NDA guarantees very low operating costs and fully automatic analysis. Last but not least, as you can see from the picture, thanks to our Velp Hermes cloud platform, it is possible to real-time monitor and manage the NDA anytime, anywhere, using a tablet, a smartphone, a computer, and to provide fast service remote support. So when dealing with multi-ingredient foods such as protein bars, the first challenge is the sample preparation. And how to guarantee sufficient homogeneity of the sample? First of all, it's worth to mention that the complexity and the multi-ingredients makes the homogenization process one of the most crucial steps for protein determination in protein bars. There are many effective ways to green samples, including the use of knife mill, of cooled mills, and in the grinding process, you have to pay special attention to do not overheat the sample, to avoid that some ingredients, such as chocolate, such as caramel, will stick to the knife of the mill and also to the wall of the grinding chamber. So for protein bars, we use a knife mill, start a grinding with 10,000 RPM for 30 seconds, and then wait to cool down and start again the process until the sample looks homogeneous. For such a complex food like protein bars that contains a combination of different ingredients like chocolate, like nuts, like fruits, it's not always possible to grind into a fine powder, but anyway we can reach a good level of homogeneity. As shown in the picture attached, we obtain a sample with a uniform composition through the entire sample matrix. So sample preparation is an essential step to obtain accurate results. And how much sample to analyze? What is the correct sample weight? In most substances, there is a relationship between the homogeneity and the sample amount. So low sample homogeneity, like protein bars, requires to measure larger sample amounts. And this is because we want to be representative of the entire samples. So for protein bars, we learn that we cannot measure just few milligrams of sample, but we had to measure sample weight up to 150 milligrams. So the NDA is a real macroanalyzer with a very wide detection range and allow the operator to choose the proper sample amount as a function of the sample homogeneity. Next step is to go through the principle of preparation to understand how we optimize the combustion of protein bars. Multi-ingredient food are typically difficult to burn, to combust due to the different combustion behaviors of the multi-components. To obtain complete combustion, we need first, high temperature combustion. The NDA is a real demand analyzer with operating temperature of the furnace over 1000 degrees Celsius. Second, the thin foil technology, because in the combustion zone, the oxidation of the wrapping material generates a short time temperature of 1800 degrees, that is so-called flash combustion, that help to achieve complete combustion of the sample. And third, very important, the software have a huge library of predefined methods for oxygen dosing to guarantee we are always working in excess of oxygen during combustion. And this is an important condition to obtain reliable results. Let's have a fast look about the flow diagram of the NDA702. So the sample is transferred to a poured chamber in the autosampler, where flow of helium or argon purge nitrogen before entering in the combustion chamber. So the sample drops down in the combustion tubes when there is the formation of the reference gas in the condition of high temperature and in the presence of catalyst and in excess of pure oxygen. Then the gas stream passes through in a very nice solution that is a Peltier cooler able to condense up to 99% of the water. And this is a very important step for routine measurements of liquid samples. So you can even measure a full carousel of water-based and liquid samples, and these steps allow the operator to have a maintenance-free analyzer, a maintenance-free step. Then the gas passed through the reduction column, where the active copper provides the reduction of the nitrogen oxide into molecular nitrogen. Before the detection, we had also two fast steps again. The first is a safe trap that removes just the 1% of the water. And the second is the auto-regenerative trap to remove CO2 for the gas stream before the detection, that is performed by a thermoconductivity detector, a TCD, and the instruments measure nitrogen as molecular nitrogen, N2. So how to set up the analysis? Preparing for analysis is actually very easy. All the functionality of the instruments are managed via software. So before starting analysis, some of the columns in the database must be filled and are mandatory. Of course, sample name, then sample weight. You can enter in the main window manually or using a balance. So you can transfer the sample weight directly to the PC. Then you have to select the proper methods that determines the analysis parameter for proper oxygen dosing to obtain complete combustion. And we will see in detail this parameter. You can choose the sample type, because samples can be managed by the software as checkup condition, to check up sample to condition the instruments in the morning, for instance, before starting samples. Can be a calibration standard, can be a quality control QC sample, or simply a real sample. And last, the calibration curve used for calibration. All the other database columns are filled automatically by the instruments at the end of the analysis. It is interesting to see in details what is a method. So the software have a huge library of predefined methods. You can also create your own customized one, and the methods determines the volume of oxygen necessary to achieve the complete combustion, depending on the sample nature and depending on sample weight. So here we created a method called protein bars with a quite high oxygen flow and a high value of the parameter oxygen factor. That is the volume of oxygen automatically dosed for milligram of samples. Moreover, in the method, you can also set the protein factor to convert nitrogen content into an estimate of the protein content in food. So for routine operation, you have just to click and select the methods, and the software automatically will dose the optimal amount of oxygen and calculate the protein content. What about the calibration? Element Analyzer provide matrix independent results. So with the same calibration, it is possible to measure any kind of sample matrix. For the calculation of the results, we use ADTA here. We obtain a very nice linear calibration on the whole range. And you can use any kind of pure substance to calibrate the unit, such as ADTA, such as aspartic acid, such as glycine. Different calibration curves can be created and managed in order to optimize the analysis of all kinds of samples. So in the software screen, at the end of the analysis, you will see the results as the percentage of nitrogen and percentage of protein. And so you have a real-time graph displaying. All the functionality of the instruments are managed via truly modern and effective software with many features, such as start analysis with few clicks, automatically test, how to sleep and wake up, maintenance menu that sends alerts when the reactor is exhausted, statistical calculation, and many other features. So let's see the results. In this table, you can see the nitrogen and protein results. And it's very interesting to know that by weighting a sample weight from 100 up to 150, we obtain a quite good repeatability. You can see here we measure quite complex samples like almond and coconut protein bars. And we can see a very repeatable results for almond bar with a nitrogen content of about 3.6 that correspond to a percentage of protein close to 22.5. While the coconut bar have a nitrogen very stable results close to 2.5 that correspond to protein of 15.5. Again, here are shown the results of fruit bar. Here we weigh 150 milligrams, so a macro samples, and we obtain very reliable and repeatable results of nitrogen of 3.35 is the average that correspond to a protein percentage of 20.93. Moreover, to test the instruments in a wide range of nitrogen content, we also measure a set of milk protein concentrated samples. That is this kind of white powder. These kind of samples are widely used as ingredients to increase the protein content in protein bars. So you can see that even with a very high content of nitrogen and with the protein roughly of 80%, we obtain very, very good results. Last, it's worth to mention how we can save resources during analysis. So the first is to evaluate the gas consumption analysis. The NDA702 have a special TCD detector designed and produced by our R&D department at Velp that do not need reference gas. So we can claim to have the lowest gas consumption for a macroanalyzer with just 220 milliliters per minute. Moreover, to reduce the cost per analysis, we can also choose between helium or argon as carrier gas. Here at the Velp headquarters, where the instruments are designed, the cost of argon is roughly 1/3 compared to helium, so you can easily reduce the cost for samples. Regarding the oxidizing gas, that is oxygen, of course, the oxygen consumption to perform an analysis is so low, just half a liter per analysis, that it's completely irrelevant. So with one bottle and with one cylinder of oxygen can last even 7, 8, 9 months in routine operation. Last, unlike traditional methods like Kildall, which involve hazardous chemicals and longer analysis time, the Dumas combustion method is faster and it's automated. So Dumas, it's a very clean technology where no hazardous reagents are used, and the long life reagents guarantee low operation cost. As a conclusion, we have a lot of instruments installed anywhere in the world, and the general feedback by our customer is that Velp instruments are easy to use and of course ideal for high throughput labs and routine quality control. Thanks for attending this webinar today. If you have time, we can go through some questions.